All right, moving on in life. We have this wonderful problem of the box being pushed by the floor, on the floor by a horizontal force. First of all, I don't even want to look at problems 6 through 8 until I have got myself a nice free body diagram to work from. And that's going to look like this. Now, we start off with a constant velocity, so that means to start off, the force is balance. So what does that mean? Let's just take it slow. First, we're given the kinetic friction. We want to know the coefficient of sliding friction between the box and the floor. So remember that friction is mu times n. And we've got a couple of other equations. We know that the applied force balances the friction and the normal balances the weight because we're at equilibrium, meaning dynamic equilibrium, meaning that we're moving at constant velocity. Basically it's this. Constant velocity means the forces balance. So let's go ahead. We realize the applied force is the friction force, which is 10 newtons. Useful? Not sure. But we know the normal is equal to the weight in this case. So we take 2.5 times 9.8. And so we know that 10 newtons from the friction is 10 equals 2.5 times 9.8 when we calculate. And so, the friction force of 10 equals mu times 2.5 times 9.8. And when we go ahead and we actually solve for that number, the answer that we're going to get is 0.41, which is D. No units on this, by the way. Now problem number 7. If the net force in the box is 1 newton, what is the applied force and the acceleration of the box? So what we know is that Fa minus Fk equals m times a, now that we're accelerating. Now, just to be clear on something, we got that the friction is 10 newtons in this problem. That means it's going to stay 10 newtons in all of these parts here. Just to be clear. And so now I'm going to get Fa minus Fk equals ma. And I got a couple things I got to solve for. So first, the net force. That means the combination of these forces, and I know that equals 1. So if I have Fa minus 10 equals 1, that means Fa is 11 newtons. That would be enough for me to pick choice D, but just to bring this home, that means I know that 1 equals m times a, and m is 2.5 from up here. So m is 2.5 times I. When I take 1 over 2.5, that's going to give me 0.4 meters per second squared. So that definitely clinches D as the answer. Finally, last part. Let us, in fact, take this free body diagram from up here, and we're going to move it down to here. And what we're going to do is this. We're told that the applied force is 0, so let's set up our equation. We have Fa minus Fk equals ma. And we're going to end up getting a different acceleration, or therefore a different time for whatever it is that we want. So we have 0 now, minus the friction force, which is still 10, again, equals 2.5 times a. So I'm going to end up getting that a is negative 4 meters per second squared. And we're traveling at 5 meters per second, so now we can use, I'm going to move this guy. You know what, I'll just leave it alone. So now we know that V is AT plus V naught, so let's go ahead and put that in our formula. V equals AT plus V naught. 0 is what we end up at. Negative 4 is our acceleration. We don't know the time, that's what we want to get. And our initial speed is 5 meters per second. So when we go ahead and solve, we're going to end up getting that T is 1.25 seconds as our final answer, C.